is still the primary medium to transfer heat from server racks to computer room air conditioners in a data center. The heat carrying capacity is affected by the airflow pattern in the room. In this chapter, we will discuss some commonly found issues that can significantly reduce the cooling capacity in a data center. In several data centers, the racks are arranged in what is called the schoolroom fashion, where all servers face the same direction like in a schoolroom. The exhausted hot air from one rack becomes the intake of the rack placed behind. Since each aisle has a row of racks taking in cold air, it is necessary to have perforated tiles in every aisle. The hot air discharged by racks is pushed up by the cold air from the floor. This makes the lower servers run cooler than the upper ones. Due to the mixing of cold air from the floor and warm air from the racks, the average intake temperature is higher, so more airflow is needed to remove the same amount of heat from the rack. Though this inefficiency cannot be fully eliminated, there are ways to minimize the thermal issues associated with schoolroom layout in a data center. Hot air discharged into the hot aisle can circulate back to the cold aisle. This happens when the volume of cold air intake of the servers is larger than what is available from the cold aisle. The hot air can have multiple recirculation paths. The hot air can recirculate around or over the racks into the cold aisle if adequate amount of cold air is not supplied. Here you can see the airflow recirculation pattern in vertical and horizontal planes. If the rack is open without enough blanking panels as shown here, the hot air can come through the open space. It is very important to use blanking panels in racks to avoid this common source of recirculation. The cold air discharged from the floor can return directly to the rack without cooling any servers. This can happen if the heat load and the airflow distribution are not matched. Excess cold air returning to cracks mixes with hot air from servers and reduces crack return air temperature. This, in turn, affects the temperature of cold air generated by the cracks and raises the underfloor air temperature. We commonly see perforated tiles placed in hot aisles in several data centers. This is primarily to keep the temperature comfortable for humans. The hot aisle is supposed to be hot, so having perforated tiles in hot aisles is a form of wastage of cold air. Similar wastage is caused by leaks from the openings on the floor made for cable cutouts that are not sealed up. In the previous chapters, we covered airflow impedance and its effect on data center cooling. The underfloor airflow impedance affects the airflow volume and distribution in a data center. It is hard to change the distribution much with just passive approaches. Primary cause of high airflow impedance is the floor height itself. Some of the older data centers with 10 to 12 inch floor height face the challenge of pushing air through constricted air path under the floor. One may not be able to do much about the floor height, but there is something that can be done. It is important to minimize the surface area of obstructions that the airflow sees. So obstructions such as cables should be tightly bundled and arranged along the direction of airflow to minimize the impedance. To cool a server rack, adequate cold air needs to be brought to the rack. It is equally important to remove the hot air from the racks without letting it mix with cold air. In many cases, the hot air finds its way back to the rack through cold aisles, or worse, it forms a stagnant pool of warm air that grows over time to cover large areas. It is very difficult to cool servers in a stagnant area in a data center. Humidity in the warm air returning to a crack hits the chiller coils in the crack and immediately condenses. The cold air exhausting the crack is now low in humidity, so most cracks are designed to humidify cold air. Cracks with different return air temperature can cause each crack to humidify at different levels, causing extreme inefficiency. Energy Star recommends using centralized controller for humidification to avoid dueling crack units. Using one crack as a primary humidifier and others as standby eliminates this issue. Our use of centralized, high-efficiency ultrasonic humidifiers can significantly reduce power consumption. Sometimes, high-power racks are placed closer to the cracks for higher cold air availability, but these racks still run hot. The primary reason is that high-speed underfloor airflow near the cracks causes lower underfloor pressure due to Venturi effect. This could be so significant that room air can flow into the floor. Negative pressure can be tested by placing a piece of paper on the perforated tile. If it stays still, the pressure is 0 or negative. This issue can be resolved by using airflow diffusers that can reduce the airspeed and cause the underfloor pressure near the cracks to increase. In most data centers, you can find spots where the underfloor pressure is lower than in other areas. Sometimes this could be in a cold aisle, leading to low or negative airflow discharge from the floor. The primary cause is that due to rotating airflow pattern caused by crack placement, underfloor vortices are created. The center of these vortices is at low pressure, so airflow from the tile is reduced or can even be flowing into the floor. It can be easily tested using the paper test mentioned before. To break up a vortex, underfloor airflow may have to be redirected using panels or diffusers. This can also be resolved using fan-assisted tiles like Hotspotter. Some data centers still use server racks with plexiglass front door. This severely restricts airflow into the rack and limits cooling. For today's high-power servers, these legacy racks can cause overheating. These doors should be replaced with perforated panel doors to enable higher airflow. Addressing some of these problems can vastly improve airflow and cooling in your data center. A CFD analysis can clearly show these issues so they can be addressed effectively. If you have any comments or questions, please do not hesitate to contact me. Thank you.